Okay, so today we are going to talk about volume of pyramids and cones. So we're switching over here. Last 2 days we've talked about the surface area. I kind of put this in the wrong order, but let's talk about just the difference between these two so we'll remember this. So surface area is what we've been doing the last 2 days. Volume is what we're going to be doing today. So what's the difference in these two? Okay, good. I mean, that's the easiest way to think about it. One's outside, one's inside. Let's be just a little bit more specific than that, but that's a good way to remember it. So the surface area is kind of like the outside layer. Okay? Or like somebody said in my first period, I thought it was pretty good, it's kind of like the skin. Okay? It's just on that very outside layer. It's the area of the outside of it. And so what's the volume then? Okay, good. It's what it takes to fill up the inside. Surface area is on the outside layer, outside skin, whatever. The volume is what it takes to fill the inside of it up. All right, so volume of a pyramid. Here's the volume formula. It's area of the base times height divided by 3. Area of the base times height divided by 3. So why is it divided by 3? Now, this doesn't prove anything, but it will show you, this will give you an idea about why it's like that, okay? So what this guy has here in this video is, he's got a cylinder and a cone that have the same diameter and they're the same height, okay? Okay, so, I mean, again, that doesn't prove anything, but it just kind of gives you an idea. It takes 3 of a pyramid to fill up the cone and cylinder work the same way. It takes 3 of those to fill up one of them. That's why this is divided by 3, because it's a third of it. Okay. So, what does the capital P stand for? All right, perimeter of the base. What does the capital B stand for? Area of the base. What does the L stand for? Okay, is the slanted or slant height. And what does the H stand for? Height. Now with prisms, the height, we always added in the phrase distance between the bases, and that's pretty much the same thing here. First of all, on this pyramid right here, which one is the slant height? 10.77. Which one's the height? 10. Is the 10. Which I think actually we did one. Yeah, we did the exact same one. And think about that. It was totally different from different places, but it's the exact same thing because it had 8 on the base also. Anyways, okay. So here's the thing. The height of a pyramid or cone for that matter, the height of a pyramid is the perpendicular distance between the vertex and the base. So the vertex is the very top point, and the base obviously is the base. So anyways, it's the perpendicular distance, so going from there straight up to the tallest point. That's the height. The slant height is the height of any of the lateral faces. So any of the lateral faces, and on a pyramid, the faces are always triangles. So the slant height is that height of that face. But for the stuff we're doing today, we're going to need the height, not the slant heights. So we need to remember the difference between those two. Okay, and then the volume of a cone is pi r squared times h divided by 3. Volume of a cone is pi r squared times h divided by 3, which really is the exact same formula as the area or the volume of a pyramid. Why are these two the same thing, but they're written different here? Good, because on a cone, it doesn't have different bases. It always has the exact same base. It always has a circle for a base. Whereas on a pyramid's kind of a generic description. It could have a square base. It could have a pentagonal base, an octagonal base. So we have to have kind of a generic thing here because capital B stands for area of the base. So that allows freedom to deal with different shape of bases.